It is exercise 7a. Exercise 7a. First question is, particle is moving with displacement function. The displacement function given is x equals t square plus 2, where x represents displacement in meters, x represents displacement in meters, and t is the time in seconds. Now this question we have to find out first the position. The position when time is given. The position when time t is equals 0. Now at t equal to 0, we just have to replace t with 0 in the above equation. That is x equals 0 square plus 4, which is obviously 4. Similarly, in B, we have to find the position when, in second case, t is given as 4. Then x equals 4 square plus 4, which is equal to 20. So displacement is 20 meter. Up in the first case, A, displacement is 4 meters. Now we have to find the average velocity. In the third case, average velocity during first 4 seconds. Okay, for first 4 seconds in part A and part B of the question, it is at time t equals 0, displacement was, we found it as 4 meter, and at time t equals 4, displacement was 20 meter. So change in displacement. Now to solve this, we'll have to find out change in displacement. Change in displacement during 4 seconds will be 20 minus 4, that is equal to 16 meter. And time taken is first 4 seconds, that is 4 minus 0, that is equal to 4 seconds. So average velocity becomes 16 meter by 4 seconds. It is based on that average velocity is equal to change in displacement by time taken. Now it is here 4 meter per second. Average velocity is 4 meter per second. Similarly, we have to do the same thing in question number 2 of exercise 7a. We have been given the equations, the displacement equations, in which we have to find the displacement during different time intervals, and we have to fill up the table. So we can easily, applying the same process, question number 2, question number 3 and 4 can be solved, and question number 4 can be solved. Now coming to next type of question, and this, we are given a particle that is moving in air as a result of an explosion, and it moves up to a certain height, that is up to 120 meter, the graph given over there is like this. In the question, the graph is given like this. The particle is moving on a path and again it lands to the ground. This is vertical motion denoted by, and the vertical height denoted by this axis, the vertical axis, and the horizontal axis gives us the time period. This is given in the question. This the maximum height achieved is 120 meter, that is in first 4 seconds. Then in the next 8 seconds, as the particle again falls towards the earth, it is at a height of 72 meter at the end of 8 seconds, and at the end of 12 seconds it again hits back the ground. So in this case we have to first fill the table that is given using different time intervals, like one is for x and the other is for t. Here this represents x and this is t. Okay, at time interval t equals 0, what is value of x? X is also at 0. The particle is also lying on the ground itself. The explosion began and it started rising upwards, vertically upwards, but at the starting of the explosion, when time interval was 0, its displacement, that is in vertical direction, was also 0. At the end of 4 seconds, it achieved the height 120 meters. So it will be written like this. Then at end of 8 seconds, it is 72 meters, and at end of 12 seconds, it is 0. Now coming to second one, B, the total distance traveled. Total distance traveled. Now the total distance traveled, as we know, distance is a scalar quantity. So it is the length of the total path traversed by the body. Here the total distance traveled will be, as the object has covered 120 meters distance vertically upwards, then again 120 meter distance vertically downwards. So total distance becomes 120 meter plus 120 meter, that is equal to 240 meter. This is the total distance covered. Now coming to third question, the average speed. As we know, average speed is total distance covered, that is 240 meter, and total time taken, that is 12 seconds. So it is 20 meter per second. In this case, if you will see the displacement, then the overall displacement is 0, because the particle starting from 0 again reaches 0 height. So the total displacement during the whole duration of time, given duration of time, it is at the same level, that is 0. It requires a height of 120 meter in first 4 seconds, then again falls towards the ground and hits the ground at the end of 12th second. So total displacement becomes 0. Now coming to D, the D part. In the D part, we have to find the average velocity during the ascent and during the descent, as well as the full 12 seconds. So during ascent, in D part, we have to find average velocity during ascent. During ascent, as again we'll move towards the graph, as we can see, During the ascent, in the first 4 seconds, it has acquired a height of 120 meter. That is, change in displacement is 120 meter. During ascent, change in displacement is equal to 120 meter, and time is 4 seconds. That is t4 minus t naught. We can write it like this. That is 4 minus 0. T naught represents the time at which this motion took place, and t4 is at the end of 4 seconds. 4 minus 0, that is equal to 4 seconds. So average velocity becomes 120 meter by 4 seconds, that is 30 meter per second. Similarly, during descent, change in displacement is final minus initial. We'll do it like this. So it will be negative 120 meter. It is because the object is falling from a height of 120 meter to a height of 0 meter. Final position minus initial position gives us minus 120 meter. Time, as we know, time is not taken negative over here. Time is 12 seconds minus 4 seconds. We get 8 seconds. So here average velocity will be negative 120 meter by 8 seconds, which equals negative 15 meter per second. In the given case, we have during this fall, you can easily observe that 120 meter and 72 meter. This was 8 seconds. This was 4 seconds. This was 12 seconds. This was 0. Descent started from 4 seconds. The descent part was from 4 seconds to 12 seconds. So the duration becomes 12 minus 4, that is equal to 8 seconds. During this 8 second, this part, the object traveled from a height of 120 to a height of 0. And during the ascent part, it traveled from a height of 0 meters to a height of 120 meters. So final position is positive 120 vertically upwards, and initial position is 0. So during ascent, displacement was positive. Ascent displacement is positive plus 120 meter. But during descent, it is negative 120 meter. So average velocity during ascent was upwards. During ascent, average velocity was upwards, and during descent, average velocity was downwards. We can easily classify, if we take upward as positive, then downward is negative. Also on the vertical axis, that is generally represented by the y-axis, part above, if we move upwards, it is always the positive part, and if we move downwards, it is always the negative part. Again, I would like to mention distance is a scalar quantity. So in case of distance, you will have to calculate the whole distance traveled by it, whole path covered by it. It is length of actual path traversed by body. But in case of displacement, we just have to find the simplest, the shortest distance between final and initial position. So in this way, we can do it. And next questions are based on average velocity, average speed. Everywhere the equation is given, displacement equation is given, we just have to put up the values of t, either t, then we'll have to find x, that is displacement, and t, that is time. And in some cases, we just have to find out displacement when displacement is given, when we will have to find out time, and where time is given, we have to find out displacement. Then we have to find out the average velocity, the average speed. So this whole exercise is based on it. Using the graphs, you have to identify whether for the given time interval displacement is positive or negative. You can, if you don't want to use positive or negative sign, you can use it as upward or downward, or towards the right or towards the left, as per given in the question. Thanks.